Hello to you watching this video. So for this video, we're going to discuss about moments of inertia. So in this module, we will deal with area moment of inertia. Area moment of inertia is an essential in structural design. So this is very important in designing for structural. So many engineering formulas, such as those being used in the analysis and design of beams and columns, involve the use of moments of inertia. Okay, so at the end of this unit, you should be able to solve the moment of inertia of a composite area, because from your physics, somehow you were able to meet moments of inertia. Okay, so moment of inertia, but for this video, by the way, we're going to discuss it in details. So moment of inertia applied to areas has no physical meaning when examined by itself. It is merely a mathematical expression denoted by the symbol I. Mathematical definition of moment of inertia. So by definition, the moment of inertia of a differential area dA about the axis x and y axis are dix is equivalent to y squared dA, and diy is equivalent to x squared dA, respectively. For the entire area A, the moments of inertia are determined by integration. So Ix is the integral of y squared dA, while Iy is equivalent to the integral of x squared dA. Okay, so this is your dA, this is your y, and this is your x. Okay, so the moment of inertia of area is sometimes called the second moment of area, because each differential area multiplied by its moment arm gives the moment area. Multiplied a second time by its moment arm, it gives the moment of inertia. So in layman's term, the moment of inertia is a physical quantity which describes how easily a body can be rotated about a given axis, or it also defines how a material is resistive of deformation. Okay, so units and sign. So SI system, it is mm to the fourth, cm to the fourth, or m to the fourth power. In US customary units, it is inch to the fourth power, or it is feet to the fourth power. Always remember that moment of inertia is to the fourth power. Okay, so the sign I is independent of the sign of the moment arm. Is independent. It depends entirely on the sign of the area. Okay, so we will further discuss that on our example. So the moment of inertia for an area relative to a line or axis perpendicular to the plane. Moment of an inertia. Moment of inertia uh, perpendicular to the plane of the area is called polar moment of inertia and is denoted by the symbol J. So the polar moment of inertia is equivalent to Ix plus Iy. So this equation states that the polar moment of inertia for an area with respect to an axis perpendicular to its plane is equal to the sum of the moment of inertia about any two mutually perpendicular axes in its plane which intersects in the polar axis. So Ix and Iy are perpendicular axes. Okay? Next would be the radius of gyration. So for the radius of gyration, it is another mathematical expression and appears most frequently in column formulas. So it is usually denoted by the symbol r. So radius of gyration is equivalent to the square root of I over a, where I is the moment of inertia and a is the cross-sectional area. So for the radius of gyration, this one helps us predict the behavior of the structure. Okay, so we use this for the design in the design to predict the behavior of the structure. Okay, next is the transfer formula for moment of inertia. It is often necessary to transfer the moment of inertia from one axis to another parallel axis. If, for example, it is a composite figure or composite, yeah, composite cross-sectional area. And we are to transfer the moment of inertia in its centroidal axis, or if we are looking for the moment of inertia at a certain axis. So we need to transfer. So for the transfer formula, we have here Ix is equivalent to Ix bar plus AD squared. So Ix bar is the moment of inertia of that structure plus the area times d squared, the distance of the centroid of that structure to the centroid of uh, the composite figure, for example, if it is a composite figure. Okay, so this equation states that for an area, the moment for any area, the moment of inertia with respect to any axis in the plane of area is equal to the moment of inertia with respect to a parallel centroidal axis plus a transfer term composed of the product of the area multiplied by the squared distance between the axes. Okay? And note that centroidal axis involved, the transfer formula is always centroidal axis of the area used in the transfer term AD. So it is a centroidal area. Okay. So moments of inertia for composites areas. Composite areas. What do we mean by composite area? Composite area is consisting of series of connected simpler parts or shapes such as rectangles, triangles, and circles. So if we combine figures and it's no longer that easy to compute for the centroid like what we did in the previous chapter, then it is already a composite area. But of course, we can break it down into simpler forms and solve the centroid. Then we use formula in order to get the centroid of that composite figure. Okay, so provided the moment of inertia for each of this part is known or can be determined about a common axis, then the moment of inertia for the composite area about this axis equals the algebraic sum of the moment of inertia of all of its parts. Okay, so on page 223 224 shows the moments of inertia for geometric shapes. And page 224 shows the properties of some structural section. So this book is the book of Casimali. Mecan I for no, it's Engineering Mechanics, Statics and Dynamics by Singer. That is the book that we are using. Okay, so you can find these tables on that book, Engineering Mechanics, Statics and Dynamics by Ferdinand Singer. Okay, next is the product of inertia. So the product of inertia for an area is the summation of the product of each differential area by its moment arms about two perpendicular reference axis. It is denoted by the symbol pxy, wherein the subscripts denote the reference axis. And the product of the inertia is required to determine the maximum and the minimum moments of inertia of an area. I repeat, the product of inertia is used to determine the maximum or minimum moments of inertia of an area. Again, the units that we're going to use is either mm to the fourth, cm to the fourth, or meter to the fourth, inch to the fourth, or fifth to the fourth. Okay? So the sign for the product of inertia depends on the location of the area relative to the axis, being positive if the area lies principally in the first or third quadrants, and negative if area lies principally on the second, fourth quadrants. Okay, so we have here our quadrant. First quadrant, positive area. Second quadrant, it is negative area. Third quadrant, positive again. And if it is on the fourth quadrant, it is a negative area. The product of inertial is 0 with respect to the axis of symmetry. If it is symmetrical, then the product is 0. So the transfer formula for product of inertia is equivalent to P sub of xy is equivalent to P bar xy plus A times x bar y bar. This equation forms the basis of the method of computing the product of inertia for areas composed of simple geometric shapes. So this is your area, and this is your uh, distance x, and this is your distance I, parallel to the axis. Okay? So we are now ready to solve for our examples. Before we proceed with our example, let me show you first the formula that we're going to use in order to solve for the moment of inertia. So these formulas are formula for different shapes, geometric shapes, common geometric shapes. So for rectangle, we have here the ix bar, the I bar, the ix, and the iy. The difference between the ix bar and the ix bar is the moment of inertia for the parts, or for the simple geometric figure, while ix is the transferred moment of inertia. But for this case, since it is a simple rectangle, ix bar and ix are the same. Likewise with iy bar and iy. Okay? So ix bar is equivalent to base. You have here the base times the height of 3 cubed. But now for the iy bar or iy, we have here the base times the height. Okay, so there will it will interchange. It will become the height times the base cube. Okay, next would be the triangle. So for the triangle, ix bar is equivalent to base times height cube over 36. Now for the iy bar, h and b will interchange. This will now become your uh, base, and this will become your height. But of course, by definition, this is still your base. Okay? This is still your base and this is your height. So magpapalit lang siya. Magiging hb cube over 36. Now for the circle, it is the same. Ix bar plus iy bar is equivalent to pi r raised to the fourth power over 4, because the dimension all throughout, or the radius all throughout this circle with respect to the center or the centroid, is the same r, or the same radius. For a semicircle, we have here ix bar is equivalent to 0.10976 r raised to the fourth power, while ix is equivalent to pi r raised to the fourth power over 8. Then iy is equivalent to pi r to the fourth and divided by 8. Now for a quarter circle, ix bar and iy bar is the same, 0.05488 r to the fourth, while ix is equivalent to pi r to the fourth over 16. Iy is equivalent to pi r to the fourth over 16. Okay, so I repeat, do not get confused with ix bar and ix, and iy bar and iy. Okay, so ix bar, the this is the moment of inertia along x-axis of the figure, while ix is the moment of inertia, transferred moment of inertia, or it is the moment of inertia of the composite figure. Okay, so let's proceed with our example. The following examples are shown to illustrate how to determine the moments of inertia and products of inertia of composite areas and built-up sections. Okay, so the shaded area, number one, the shaded area shown has an area of 5" squared. So it has an area of 5" squared, and the moment of inertia of 30" about axis x1. So this is axis x1. Find the moment of inertia about axis x2. So we can solve for the moment of inertia about axis x2 if we can solve for the moment of inertia about the centroid, and that is x of naught. Then from there we can from here we can solve that using the transfer formula. Okay, so we have here ix1 is equivalent to ix naught plus ad squared. Okay, so the moment of inertia with respect to x1 is equivalent to 30. So 30 is equivalent to ix naught plus what is the area? The area is 5, so that is 5 times the distance. What is the distance of x1 to x naught? That is 2 inch. So times 2 quantity squared. So ix naught is equivalent to plus 5 times 2 quantity squared. Shift solve. That is equivalent to 10 inch to the fourth. Then since we already have our IXO or IX naught, we can now solve for IX2. So IX2 is equivalent to IX naught plus AD squared. So IX naught is equivalent to 10 plus what is the area? The area is 5 times the distance from x naught to x2. That is 3. So 3 squared. Therefore, that is equivalent to 55. 55 inch to the fourth. That is IX2. Next, we have here number 2. Determine the moment of inertia of the T section shown in the figure about its centroidal x naught axis. So also compute the radius of gyration of the area with respect to x naught axis. Okay, so first thing that we need to do is to determine what is our y bar, what is the centroid. So the centroid, since with respect to y-axis, it is symmetrical. So we know that the centroid, this is the centroid for with respect to the y-axis, but the centroid for x is unknown. So we need to determine the y bar. And we can have our reference with respect to the top, to this part here, or the bottom. So in my case, in our case, I will have my y uh, or 0 with respect to the bottom. Okay? And this would be my y bar. Okay? So since this is a composite figure, what I'm going to do is to divide it into its simpler form or into parts. So I'll be having here two rectangle rather, dalawang magiging rectangle ko. We have here part 1 and I have here part 2. So you have part 1, you have part 2, and you have here the total. Okay, so what would be the area? So the area is 6 times 2. You have for the table, so we will be using table to solve um, the moment of inertia easier. Mas madali pag naka-table and mas organized. Okay, so we have here part 1, we have the area, the area times y, the moment of inertia, the distance with respect to the moment of inertia, the centroid, and we have area times the centroidal distance. Okay, so for the area of part 1, we have 6 times 2, that is equivalent to 12. Next, for part 2, that is 6 times 2, that is equivalent to 12. Therefore, the total area here is 24. Okay, now for the y, this is my reference here, reference axis ko ito. Okay, so this is 0. So for part 1, the y is 6 plus half because the center is acting here. Okay, so that is 2 divided by 2, that is 1. Therefore, the y here is 7. Next, for the y here, it is acting at the center, so that is 6 divided by 2, that is 3. Okay, now for the a times y, we have 12. 12 times 7, that is 84. Then we have 12 times 3, that is equivalent to 36. The total AY is 36 times 84. That is 120. Okay? So, yeah. Okay. Next is to solve for the y bar. Actually, we can proceed with our moment of inertia, but let's first solve for our y bar. To solve for the y bar, we will be using the Varinian's theorem. So according to Varinian's theorem, the area total times y bar is equivalent to the summation of the area times their y distances. Okay? So what is the area total? The area total is equivalent to 24. So 24 times y bar is equivalent to the summation of ay, and the summation of ay is 120. Y bar cross multiply, we have y bar is equivalent to 120 over 24. And y bar is equivalent to 5. So 5 inch. So this is equivalent to 5 inches from the bottom. Okay? Okay. Okay, so we proceed with our IX bar. So for our IX bar, we have for shape number 1 or part number 1, it is a rectangle. Okay, so we have the base of 6 times the height of 2 raised to the third power divided by 12. Okay, next for the IX bar of the second figure, we have base of 2 times the height of 6 raised to the third power over 12. This formula is the formula that I have shown you a while ago. Okay, so we have here 6 times 3 raised to the third power over 12, and that is equivalent to 13.5. Then we have here 2 times 6. Wait. Mali. 6 times 2. No, this is 2. So this is not 36. 6 times 2 cube over 12. No, this is not 13. It is 4. So next we have 2 times 6 raised to the third power divided by 12. That is 36. Next is the distance. The distance that we are pertaining here is the distance of the centroid of the composite figure to the distance of the centroid of the simple figure. Okay? So we have here 5. No, the distance here is 7 minus 5. So we can get this distance here. So this is D1. So this is D1. Then this one here is D2. Okay. So for D1, it is 7. We all know that the centroid to the bottom is 7. So we have here 7 minus 5 because y bar is 5. And that is equivalent to 2. Next, we have here 6 minus 5. No. 5 minus 3. Centroid is 3 minus 5. So 5 minus 3, that is equivalent to 2. Okay? So we can now solve for AD squared. So what is our AD squared? Our area is 84. No. Area is 12. 12 times D squared times 2 squared. That is 48. Next, we have 12 times 2 squared, the same. We have 48. And AD squared, the summation is 48. That is 96. Okay? So, we can now solve for our IX, or the moment of inertia, the transferred moment of inertia, or the moment of inertia of the composite figure. So IX Ix naught is equivalent to the summation of Ix bar plus the summation of AD squared. Okay, so what is the summation of this? This is 40. So that is equivalent to 40 plus the summation of AD squared plus 96. That is equivalent to 96 plus 40, 136. And the unit is in inch. So that is in inch to the fourth. That is the centroidal moment of inertia. Next is the radius of gyration. So for the radius of gyration, our formula is Rxo over Ix is equivalent to Ixo over area square root. So what is our Ixo? Since we solve for the Ixo, therefore our radius of gyration is also Ixo. So we have here 136 divided by the area of 24 square root. Rx naught is equivalent to the square root of 136 over 24. That is 2.38 inch. Okay, so we have here number 3. So find the moment of inertia about the indicated y-axis for the shaded area shown. So this time, it is on the y-axis. Therefore, the moment of inertia that we're going to solve is Iy bar. Okay, so we have the composite figure here. So if you're going to observe by observation alone, if we are going to directly solve uh, the moment of inertia, it will be a big question mark on how. But if we are going to divide it into simpler form, then that would be a lot easier. So if first is you have here the triangle, next you have here the square, and you have here the quarter circle. Now take note that the quarter circle here is a void. Okay, it is a void. Therefore, all the values for the quarter circle here is negative. We are going to subtract it. Okay, we are going to subtract it. So let's proceed. First, since we already subdivided into simpler forms, we have the triangle, square, and the quarter circle. Let's now solve for the area. So for the area, since this is a triangle, it is 1/2. So 1/2 times the base of 6 times the height of 4. And that is equivalent to 0.5 times 6 times 4. That is 12. Next, for the square, we have 4 times 4. That is 16. So 4 times 4, that is equivalent to 16. Then for the quarter circle, it is pi over 4 times 4. So pi over 4, because it is a quarter, times the radius of 4. And that is equivalent to pi. It's simply pi. Okay? No. This is squared. So this is pi r squared nga pala. So we have 12.57. That is negative. 12.57. Bakit siya negative? Because it is a void. Okay? Now for the Iy bar, we have here the formula for triangle, for the moment of inertia of a triangle for Iy bar. It is hb cube over 36. Then for a square, Iy bar is equivalent to bh cube over 12. But essentially, itong triangle, it is still as bh cube. We just, for purposes na hindi magkalituhan, we just use hb cube. Then for the quarter circle, ix bar minus Iy bar is the same to be 0.05488 r raised to the fourth power. Now for the triangle, we have here what is our uh, base. So our base here is this. So our base is 4 times the height of 6. So base of 4 times the height of 6. This time ang height natin is 6 to the third power divided by 36. And that is equivalent to 4 times 6 raised to the third power over 36. That is 24. Next, for the square, we have the base of 4 times the height of 4 cubed over 12. So we have 4 times 4 raised to the third power over 12. That is equivalent to 21.33. And next we have the quarter circle, which is 0.05488 times 4 to the fourth power. So 0.05488 times 4 raised to the fourth power. That is 14.05. Okay? And that is negative. Tama ba? 0.5488. Okay. That is negative 14.05. Bakit siya negative? Negative siya because that is a void. Okay? Next would be our D. This time, we are not going to use with respect to our centroidal axis because as indicated in the problem, the moment of inertia about the indicated y-axis. So we don't need the centroidal axis. Okay? So we are only going to use the distance D. So the distance D for the triangle, it is the centroid is acting 1/3 from the base. So if this is my base, this one is my base here, then this is 1/3. Tama? This is 1/3 of 6. Therefore, this distance here is 2/3 of 6. And 2/3 of 6 is equivalent to 4. Okay? So the D here is equivalent to 4. Next, this is a square. So it is the square has its centroid at the center. Okay? So that is 6 plus the center of 4, which is 2. So 6 plus 2, that is 8. Okay? The x bar here, or the centroid, is equivalent to 4r over 3 pi for a quarter circle. So that is equivalent to, what is 4? What is r? 4 times 4 divided by 3 pi. Therefore, the centroid from the center of the circle is 4 times 4 divided by 3 times pi. And that is 1.7. 1.7 inch. So the distance with the distance of the centroid of this quarter circle with respect to our y-axis is equivalent to, this is 6 plus 4, that is 10. So 10 minus 1.7, that is equivalent to 8.3, and that is distance D. So we can now proceed solving for our A. So AD, our area is 12 times 4 squared. We have 192. Take note, yeah. Next, we have 16 times 8 squared. We have 1024. Next, we have negative 12.57 times 8.3. We have negative 104.331. And the total, or the summation, is equivalent to 1111.67. And the total IY bar is equivalent to 24 plus 21.33 minus 14.05. That is equivalent to 31.28. And the total area is 12 plus 16 minus 12.57. And that is equivalent to 15.43. Okay, so we can now solve for our IY using the transfer formula. So IY is equivalent to IY bar plus AD squared, or the summation. So IY is equivalent to the summation of IY bar plus the summation of AD squared. So the summation of IY bar is 31.28 plus the summation of AD squared is 1111.67. IY bar therefore is equivalent to 31.28 plus 111.67. That is equivalent to, no. We forgot to square the distance d. So this is incorrect. No? So we have here area of 12.57 times 8.3 quantity squared. So that is negative 865.95. Okay? So the summation therefore is also incorrect. So 192 plus 1024 minus 865.95. So that is 350.05. So this is incorrect. So this is equivalent to 31.28 plus 350.05. So IY bar is equivalent to 31.28 plus 350.05 is equivalent to 381.33. The unit is in inch, so that is inch to the fourth. And that is the final answer. Okay, so we have here problem number 4. The cross-section of a culvert is shown in the figure. Compute the moment of inertia about the horizontal axis. So we have here the horizontal axis, x, and we need to compute the moment of inertia. Therefore, we are going to solve the I of x. Okay, so we have here the culvert. So if you're going to check, the culvert is quite a complicated cross-section, but we can solve it easier if we are to break it down into into simpler forms. Okay, so what we're going to do here is to break it down into simple geometry. So we have here a triangle, we have here a rectangle, and we have a void of a semicircle. Okay, so since this is a void, the semicircle is a void, therefore it will become negative. So we can now solve the area, the moment of inertia, the distance d, and the AD squared. So for the square, it is 6 by 6. So 6 times 6, that is equivalent to 36. Then for the triangle on the right, we have a base of 3. So that is 1/2 times a base of 3 times a height of 6. And that is equivalent to 0.5 times 3 times 6. That is equivalent to 9. Then the triangle on the left, that is the same, 1/2 times 3 times 6, that is equivalent to 9. Then for the semicircle, for the circle, it is pi r squared. Since this is a semicircle, it becomes pi r squared over 2. So pi over 2 times the radius of 4 quantity squared. So we have shift I over 2 times 4 squared. That is equivalent to 25.13. Negative 25.13. Negative because that is a void. Okay? So we can now proceed with the ix bar. So for the ix bar, let's for a square, it is simply a base of 6 times a height of 6 divided by 12. Bh cube. So this is to the third power. So we have 6 to the fourth power divided by 12. So that is 108. Next we have the triangle. So for the triangle, it is bh cube raised to the bh cube divided by 36. So we have a base of 3 times a height of 6 raised to the third power over 36. So 3 times 6 raised to the third power over 36. And that is equivalent to 3 times 6 raised to the third power over 36, 18. So these are 18. Okay? Then for the semicircle, based from the formula that I gave you, Ix bar is equivalent to 0.10976 times the radius of 4 raised to the fourth power. And that is 0.10976 times 4 raised to the fourth power. That is 28.1. So that is 28.1. Okay. Now for the distance, let's start with the square. Take note that the centroid of the square is at the center. So this is the center. That is the center there, and the distance from x1 would be distance 1. And this distance 1 is equivalent to, that is 4 minus 3 is equivalent to 1. Therefore, that is equivalent to 1. Next, for the right triangle, take note that the centroid of the triangle is acting 1/3 from the base. So if this is the base, we have here 1/3 of 6 is equivalent to 2. Okay? So the distance 2 here, the distance 2 from the centroid of the right triangle to the x is 4, because of the radius, 4 minus 2, that is equivalent to 2. Okay? Therefore, we have here 2. Likewise for this one, that is 2. Now for a semicircle, the centroid of a semicircle is 4 4r over 3 pi. So from the base, we have here y is equivalent to 4r over 3 pi. And that is equivalent to 4 times the radius of 4 divided by 3 pi. And that is equivalent to 1.7. So from here to there, or from the centroid here, that is distance 3. Let's say that is distance 3, and distance 3 is equivalent to 4 minus 1.7, and that is equivalent to 2.3. Okay, so 2.3. So we can now solve for AD squared. So for the area, we have here 36 times 1 squared. Of course, that is still 36. Next, we have area of 9 times the distance of 2 squared. That is 36. Therefore, this is also 36. Then for the semicircle, negative 25.13 times the distance of 2.3 quantity squared. That is negative 132.94. So get the sum. Plus 36 times 3, that is negative 24.94. Then for the moment of inertia, 108 plus 18 times 2 minus 28 here, 0.1, that is equivalent to 115.9. Then we have here for the area 36 plus 9 minus 25.13. So we have here 28.87. Okay, now for the moment of inertia, which is Ix is equivalent to the summation of Ix bar plus the summation of AD squared. So what is the summation of Ix bar? We have 115.9 plus AD squared. We have negative 24.94. Ix therefore is equivalent to 90.96. And the unit is in inches, so that is in inch raised to the fourth power. So that is Ix bar. So we have here problem number 5. A plate and angle column is composed of 4 8 by 4 by 1 inch angles. So we have here angle bars, apat, and with short legs connected to the web. So the short leg is connected, the short leg is 4 inch, so this is the 4 inch, this is the 8 inch. Okay, and it is connected to a web plate of 14 inch by 1 inch. So this is the web, it is 14 by 1. So if you're going to look closely, you have a space there, you have a space. Okay, that space is, since this is 14 and 1 half, 0.5, so that is 0.25 inch. Okay, so we have the flanges, which is 18 by 2 and 1/4 inch thick. So 18 inch wide, and the thickness is 2 and 1/4 inch. So you have here the web, the flange, the angle bars. Okay, so we can now, if you're going to look at it as it is, it is quite complicated. But if you're going to dissect it into its part, then it would be a lot easier. And if you're going to check it with respect to the y and the x axis, it is symmetric. So since that would be the case, the distances with respect to the individual center or the centroid of each member with respect to the centroid of the composite figure are the same, pwede nating pag-isahin. We can combine the parts. For example, we have here the flange. We have 2 flange, so I'm going to combine it. I have here 4 angle bars, so I'm also going to combine it since the distance would be the same. Okay, so let's start with the area. So what would be the area? So that is 14 times 1, of course, that is 14. Next, you have 18 times 2.25. So that is 18 times 2.25 times 2.25 times, take note, you have 2 here. So there are 2 flanges. So times 2, that is equivalent to 18 times 2.25 times 2, that is equivalent to 81. Okay, next would be the 8 times 4 times 1. So what do we mean by that? 8 for the long member, 4 inch for the short member, then the thickness is 1. So we can do is 8, cut it there. Take note, the thickness here is 1. So if I am going to cut it there, it would only be 7. 7 times 1, and we have here 4 times 1. But since that is an angle bar, what I can do is to refer to a textbook. So I have here a textbook which is strength of materials, and you can also have the textbook still books. But for our case, this is what we use for mechanics of deformable bodies. That would be the next subject after statics rather. So this would be a good reference. Okay. So at the back of this book, we have here the different sections of steel. So we have here meron tayo ditong um, wide flange, we have angle bars, we have I-beam. Okay? So, yeah, meron tayong mga properties dito. So, what I'm going to do is to look on the angle bar and hahanapin ko yung 8 by 4 by 1. So, for the 8 by 4 by 1, I have here 8 inch by 4 inch by 1 inch. That the thickness is, the dimension is in inch. Therefore, the area for the 8 by 4 by 1 is 11. Okay? So, that is 11. And take note, there are 4 of them. So, 11 times 4, that is equivalent to 44. Okay? Next would be the IX bar. So, for the IX bar, we have here the base, dito pala tayo sa web. So, for the web, it is a base of 1 and a height of 14. Take note, it is not 14.5, it is 14. So, base of 1 times a height of 14 raised to the third power divided by the base of 12 because that is a rectangle. So, that is equivalent to 14 raised to the third power divided by 12. That is equivalent to 228.67. Okay? Next is for the flange. So, for the flange, it is 18, base of 18 times a height of 2 and 1/4. So, that is 2.25. 2.25 raised to the third power divided by 12. So, 18 times 2.25 raised to the third power over 12. That is 17.09. But do not forget that we have 2 of this flange. So, times 2, that is equivalent to 34.17. Okay? Next is the 8 by 4 by 1. So, what is the IX? So, I am going back to my textbook. But before we proceed, if you're going to go directly, sabi kasi dyan, IX bar. So, what I'm going to do is I am going to check on the x-axis. So, this is now IX bar. So, for the y-axis, this is IY. So, for the IX, if I'm going to check it here, it is 69.6. But be careful because the orientation of these properties here is this way. This is the orientation. But if I am going to check my problem, the orientation is tilted 90 degrees. Okay? So, from an original position of this, for these properties, it is now tilted this way. So, since it is tilted this way, since it is tilted this way, this the ix the ix here will now be my iy, and the iy here will be my ix. Nagpalit sila, they interchanged. Okay, I repeat, since it is tilted from this orientation to this orientation, what I am going to consider for my ix would be the iy. What I am going to consider for the iy would be the ix. Okay? So, here I am looking for ix, but I am going to consider iy because it is tilted, and IY is equivalent to 11.6. Okay, so that is 11.6. Take note, there are 4 of them, so times 4 is equivalent to 11.6 times 4, that is 46.4. Okay, next would be the distance D. So for the distance D, it is the distance of the centroid of each individual figure with respect to the centroid of the composite figure. So what we consider here is the web. So the web here, this is the web. The centroid of the web is located at the center. And the centroid of the composite figure is located also at the center of the web. Therefore, the distance is 0. Okay. Next would be the flange. So this is the flange. If it so happen that the distance of the centroid of the flange on the top is different from the distance of the centroid of the bottom with respect to the centroid of the composite figure is different, we need to separate these two. Like for example, the distance here is 7, but the distance here is 8. Then we need to separate these two. But in this case, everything is symmetrical with respect to x and y axis. Okay, so the distance is the same. So we have here the thickness of 2.25, and we know that the centroid is acting at the center. So 2.25 divided by 2, that is 1.125, plus half of 14.5 plus 14.5 divided by 2. Therefore, D is equivalent to 8.375. Next would be the flange, the web, the angle bar rather. So for the angle bar, take note that the centroid is acting here. The centroid is also acting here. Okay? But with respect to x and y axis, they are all symmetrical. So we can only consider one. Okay? We're only going to consider one. But if they are not symmetrical, paghihiwalay natin to. We need to split this 4. But since it is symmetrical, we can consider one only. So we have it here. Okay? And we also have it here. So from the table, the orientation is this way, diba? But the orientation in the problem is this way. Therefore, the this distance here is x bar. Okay? This distance here is the x bar. So x bar there, what is x bar? Ito, this is this is x. So x, so wait. No. Wait. So this is x, this is y. Okay? So this is x, this is y. This is x, this is y. So for x, what is x here? Yung x natin dito, that is x bar 1.05. 1.05. Then for the y natin there, it is 3.05. Okay? So that is 3.05. Okay? So for the x distance, it is 14.5 divided by 2 because that is half minus 1.05. Okay? So 14.5 divided by 2 minus 1.05. And that is 6.2. So from the centroid of this angle bar to x to the centroid of the composite figure is 6.2. So we can now solve for our values. Okay? Okay. So I just adjusted my camera. So we have here 14 times 0. So that is 0. Area 81. So we have here 81 times the distance of 8.375 squared. So that is 5,681.39. Then next we have it here 44. 44 times 6.2. 6.2 squared. We have 1,691.36. Okay? So let's get the summation. 14 plus 81 plus 44, 139. Next we have 228.67 plus 34.17 plus 46.4. We have 309.24. Next we have the AD squared. 5,5681.39 plus 1691.36. So that is 7,372.75. Okay, so we can now solve for Ix. So Ix is equivalent to the summation of Ix bar plus the summation of AD squared. So what is the summation of Ix bar? We have 309.24 plus this, the summation of AD squared, and that is 7,372.75. Ix bar therefore is equivalent to 7,681.99 inch raised to the fourth power. That is Ix. Next, we have the Iy naman. This time, it is the Iy. This time naman, it is the Ix. Bale. This is Ix. This is Iy. So, we simply copy the area. We have 14, 81, 44. So, that is 139. Okay. Next is the Iy. So, the Iy, it is now, the X and the Y will interchange. So, for the flange, for the web, we have a base of 18. We have a, no, that's 14 pala. We have a base of 14 times a height of 1. Okay? So, times 1 raised to the third power divided by 12. Next, for the flanges, we have here a base of 2.125, 2.25. It is 2.25. Yes, 1/4. So we have a base of 2.25 and a height of 18. We have a height of 18. Base of 2.25, height of 18. Times 18 raised to the third power. Divided by 12. Okay. Next is our angle bar. So for the angle bar, since this is the orientation here, so if this is the orientation, this is my Ix, this is my Iy. Okay? So, since nag-tilt siyang ganyan, magpapalit. I am now going to consider here the Ix. Okay? What I'm going to consider here is Ix. Kung kanina kinonsider natin is Iy, which is 11, this time what we're going to consider is Ix. That is 69.6. So, we have here 69.6. So, for the flange, we have 2, so times 2. For the angle bar, we have 4, so that is times 4. Okay, so we have it here, 14 divided by 12. That is 1.17. 2.25 times 18 raised to the third power divided by 12 times 2. So that is 2,187. then 69.6 times 4, that is equivalent to 278.4. Okay, now for the distance, this is the centroid. This is the centroid for the y-axis. Okay, the location of the centroid for the y-axis is here. So if we're going to start with our web, again, the centroid of the web is located at the centroid of the composite figure. So D is 0. Now for the wide flange, this is the wide flange. The center of the wide flange is located here. The centroid of the composite figure is also located here. Therefore, it is 0. So last but not least, we have the web members. So for the web members, what we're going to consider is the y. So from the centroid of the web to take note that this 3.05 here is the distance from the center to the end of the angle bar. So hanggang dito lang siya. So from this point up to the center of the web member is 0.5. Okay, so if you're going to check it there, from the angle, from the last fiber of the angle bar to the center of the web, that is 0.0 that is 0.5 inch. Okay, because this web here is 1 inch, so half is 0.5. So therefore the distance is 3.05 plus 0.5, that is 3.55. So area times 0, 0, area times 0, 0. 44 times 3.55 squared, that is equivalent to 554.51. So get the sum, 1.17 plus 2187 plus 278.4. So that is 2466.57. Then we have here 551.51. So we can now solve for IY rather. So IY is equivalent to the summation of IY bar plus AD squared. So IY, the summation of IY is equivalent to 2466.57 plus 54.51. So IY is equivalent to 2466.57 plus 554.51. 3021.08, and that is inch to the fourth, and that is IY. Okay, so we have here problem number 6. This time we are already in product of inertia. Okay, so compute the product of inertia of the triangular area shown in the figure with respect to the given x and y axis. So this is the y and the x axis. So for the product of inertia for a right triangle, we have here pxy is equivalent to negative b squared h squared over 72. Okay, so this is our problem here. We have here a 9 by 9 triangle. So what we need to do is to divide it into a right triangle. Okay, so I will have here my cutting plane. So I now have two right triangle. So let's say that this is triangle 1 and this is triangle number 2. Okay, so for the area, we have 3 by 9. So we have 3 by 9, and of course times 0.5 because it is a triangle times. So times 0.5, that is 13.5. Then for number 2, it is 9 minus 3, that is 6, times a height of 9 times 0.5, and that is equivalent to 27. Okay? Now for px or p, px pxy bar, take note we have the formula here. Pxy bar is equivalent to negative b squared h squared over 72. Okay, so since this is my cutting plane, this would be my reference. Okay, so I'll be having my reference here. So this is on the positive side, this is on quadrant 1, then this becomes on this now becomes a part of quadrant 2. So since 1 is part of quadrant 2, it is negative of negative. So negative of negative, what is the base? We have a base of 2, base of 3 squared. No. Dapat nakalabas yung negative. So 3 squared times height of 9 squared divided by 72. So negative times negative magiging positive. Okay? Next would be the second triangle. So the second triangle is on quadrant 1. So that is positive. So we have negative, kasi negative yon. Ito kasi nandito sa quadrant 2. So negative times negative naging positive. Okay? So we have negative 6 for the base times 9 for the height divided by 72. Okay? So we have here 3 squared plus 9 squared divided by 72. And that is equivalent to 1 point mali. It should be times, not plus. So we have 10.125. Next we have 6 and we have 9. That is 40.5 and that is negative 40.5. So the total is negative 30.375. Now for the x bar, we know that the centroid is acting 1/3 from the base. So ito yung base ko, this is 2/3 of x or 2/3 of 3, and that is equivalent to 2. So therefore x bar here is 2. Then here we know that it is acting 1/3 from the base. So ito yung base ko, ito rin yung base. With respect to x and y, it is 1/3 of 6, and that is equivalent to 2. 2 plus 3, take note, 2 plus 3, that is 5. Therefore, the x bar here is 5. Okay? Now, for the y bar, it is here. It is located here. So, for the y bar, it is 1/3 of 9. And that is equivalent to 3. Therefore, y bar is 3. Likewise with our triangle number 2, that is also 3 because they have the same height. Okay, so for the area times x bar times y bar, that is 13.5 times 2 times 3. That is equivalent to 81. Next we have 27 times 5 times 3, that is equivalent to 405. And to get the sum, we have 405 plus 81, that is 486. Therefore, pxy is equivalent to pxy bar, the summation, plus the summation of axy bar. Okay, so we have it here, What is the summation of pxy bar? We have negative 30.375 plus 486, and that is equivalent to 455.625, and that is in inch to the fourth. So that is pxy, and that is the final answer. We have here number 7. Find the product of inertia of the shaded area as shown in the figure about the specified x and y axis. So this is the y axis, this is the x axis. So we are to determine the product of inertia. So what we're going first to do is to divide this into simpler geometric forms. So we have here the rectangle, I have here the triangle, and I also have here the semicircle. Okay, so for the rectangle, it is 3 inch by 6 inch. So we have 3 times 6, that is 18. Next, for the triangle, it is 6 by 3 because the total base here is 6. The base at the top is 3. So that would be 3. Okay, so 3 times 6, 3 times 6 times 0.5, and that is equivalent to 9. And then for the semicircle, we have here pi r squared divided by 2, and the radius is 3. So it is 14.14, and that is the area. Now the for the product of inertia for the rectangle, if you can see here, for example, this ruler, this is a rectangle, right? So with respect to y-axis, it is symmetric. With respect to x-axis, it is symmetric. Therefore, the product of inertia is equivalent to 0. If there is symmetry with respect to the two axes, it is 0. Okay? So this one, we have here the semicircle. So the semicircle is symmetric with respect to x-axis. Therefore, it is also 0. Now for the triangle, we know that the formula of the triangle is negative base. What is our base? Negative 6 squared times the height of no, this is just 3 squared times the height of 6 squared over 72 from the formula on our previous example. So that is negative 3 squared times 6 squared over 72, and that is equivalent to negative 4.5. Okay, so for the x bar, ano ba yung x bar na tinutukoy natin dito? This is the x bar. Then for the y bar, ito naman, this is our y bar. So x1, y1. Then for the square, we have it here. For the triangle, we have it here. For the triangle, we have it here. So ito yung mga x natin. So we have x2, and this here is x1. Then we have here y3, and we have it here as y2. Okay, so for the x1, it is 4r over 3 pi. So for x of the rectangle, it is simply 1.5 because it is the center, 1.5 of center of the 3. Then for the triangle, it is 1/3 from the base. So this is the base. So 1/3 of 3 is 1 plus 3. So that is 4. Okay? I repeat, for the triangle, it is 1/3 of the base. Yung x1 natin is 1/3 of 3 plus 3. And that is equivalent to 4. Okay? Now for the semicircle is equivalent to 4r over 3 pi. So x1 is 4r over 3 pi. And that is equivalent to 4 times the radius of 3 over 3 pi. So cancel. So 4 divided by pi is equivalent to 1.27. So x bar here is 1.27. Now for the y bar of the square, it is 6 divided by 2, so that is 3. Now for the triangle, it is 1/3 of 6, and that is 2. Now for the semicircle, it is 3. Okay, so we can now solve for the AXY. So we have 18 times 1.5 times 3, that is 81. Next, 9 times 4 times 2, that is 72. Then we have 14.14 times 1.27 times 3, and that is equivalent to 53.87. But take note that this is negative because that is a void, so that is minus. Okay, so for the total, we have here 81 plus 72 minus 53.87, and that is equivalent to 99.13. Now for the p, it is simply negative 4.5. Okay, so with that, we can now solve for our product of inertia. So pxy is equivalent to the summation of pxy bar plus the summation of axy bar. So what is the summation of pxy bar? That is negative 4.5 plus the summation of axy bar, that is 99.13. Therefore, the product of inertia is equivalent to 94.63, and that is in inch to the 4th power. So we have here problem number 8. This time we're going to be dealing with moment of inertia about or with respect to inclined axis. Okay, so if it is with inclined axis, there will be, of course, there will be two axes. You will be having the u-axis or the v-axis. So if we are to determine the u-axis, we will be using the moment of inertia with respect to u-axis, we'll be using this equation. So ix plus iy over 2 plus ix minus iy over 2 cosine 2 alpha minus pxy sine 2 alpha. If it is iv, with respect to iv naman, it is ix plus iy over 2 minus ix minus iy over 2 cosine 2 alpha plus pxy sine 2 alpha. But for this problem, for a rectangular area shown in the figure, find the moment of inertia about the inclined u-axis. So we will only use this formula. So if we are only to use this formula, what are the values needed? We need to determine the ix, the iy, and the pxy. So we can now start solving. So for ix, it is simply bh cubed over 3. and that is equivalent to the base of 12 times the height of 6 raised to the third power divided by 3. So that is equivalent to 12 times 6 raised to the third power over 3. That is equivalent to 864 inch to the fourth. Okay, next is IY. So for IY, we have the base of 6 times the height of 12 raised to the third power divided by uh, 12. Wait, wait. No. Why is this 3? This should be 12. Okay? No, this one should be 12. So, yeah, that will simply cancel out. 6 cube. We have 216 inch to the fourth. So, 216 inch raised to the fourth power. Then for the IY, it is 6 times 12 raised to the third power divided by 12. And that is 864 inch raised to the fourth power. Now for PXY, isn't it that PXY is equivalent to PXY bar summation plus the summation of AXY bar. Okay, so for PXY bar, since this is a triangle, with respect if we are looking at the center, there is symmetry with respect to x and y axis. Therefore, PXY bar is equivalent to 0. Now, plus what is the area? It is 6 times 12. So, 6 times 12. Then x bar is 6. Then y bar is 3. So, times 6 times 3. Therefore, PXY is equivalent to 6 times 12 times 6 times 3. That is 1,296. And that is inch raised to the fourth power. Then we can now solve for our IU. So IU is equivalent to, what is IX? IX is 216 plus 1,296 over 2 plus 216 minus 1,296 divided by 2 cosine 2 of the angle with respect to the horizontal, that is 30 degrees, minus PXY 1,296 sine 2 of 30 degrees, and that is equivalent to 216 plus 1,296 over 2 plus 216 minus 1,296 over 2 cosine 2 times 30 minus 1,296 sine 2 times 30 is equivalent to negative. Okay, so that is negative 636.37. Next we have here is moment of inertia with respect to inclined axis. Okay, so if it is inclined, we will be having two additional axis. So you have the u axis and you have the v axis. So for the moment of inertia with respect to u axis, it is simply ix plus iy over 2 plus ix minus iy over 2 times cosine 2 of alpha. That is the angle here, minus the product of inertia sine 2 of alpha. Now for the v, the moment of inertia with respect to v axis, you have ix plus iy over 2 minus ix minus iy over 2 times cosine 2 alpha plus the product of inertia times sine 2 of alpha. Okay, so for the product of inertia of u and v, that is equivalent to ix minus iy over 2 times sine 2 alpha plus p product of inertia of x and y times cosine 2 of alpha. Now for maximum and minimum moment of inertia, so this is for the x and y. So maximum or minimum moment of inertia, we have ix plus iy over 2 plus or minus, plus and minus, times the square root of, no, it is ix plus iy over 2 plus minus the square root of quantity ix minus iy over 2 quantity squared plus pxy squared. So that is our additional information or formulas. Okay, so we have here problem number 9. Find the minimum and the maximum moments of inertia with respect to the axis through the centroid of the 9-inch by 6-inch triangular area shown in the figure. Also, compute the moment of inertia with respect to the given centroidal axis u. Okay, so we are to determine the y, x, and u axis. Moment of inertia with respect to these three axes. Okay, so from our previous example, we are having an additional equation of I max min. So we have ix plus iy over 2 plus minus the square root of ix minus iy over 2 quantity squared plus pxy quantity squared. So we need to solve first for ix, then for iy. Okay, so for ix, we have the base times the height of 6 times 9 raised to the third power over 36 for a triangle. And this is equivalent to 6 times 9 raised to the third power divided by 36, and that is equivalent to 121.5 inch raised to the fourth power. Then for iy, this will be my base and this will be my height. So we have 9 times 6 raised to the third power divided by 36. And that is 9 times 6 raised to the third power over 36. And that is equivalent to 54 inch raised to the fourth power. Okay. Next, we have the pxy. So for the pxy is equivalent to the summation of pxy bar plus axy bar. Okay? But be careful, no? Because here, we are to compute the moment of inertia with respect to the centroidal axis. And if this is the figure, this is our centroid y, this is the centroid x. Therefore, axy is 0. Okay, so this will simply cancel out. Therefore, pxy is simply pxy bar. Okay, so pxy bar is equivalent to negative b squared h squared over 72. Okay, so substituting, what is our b? We have a base of 6 squared, that is negative, times 9 squared divided by 72. Therefore, pxy bar is equivalent to negative 6 squared times 9 squared over 72. And that is equivalent to negative 40.5, and that is inch to the fourth power. Okay, so we can now solve for IU. So IU is equivalent to what is IX? IX is 121.5 plus, we have here, what is IY? We have 54 over 2 plus, what is IX? We have 121.5 minus 54 over 2 times cosine of 2 times the 35-degree angle minus pxy, and that is negative 40.5, and times sine 2 of 35 degrees. So IU is equivalent to 121.5 plus 54 over 2 plus 121.5 minus 54 over 2 times cosine 70 minus negative 40.5 sine 70, and that is equivalent to 137.35 inch raised to the fourth power. Now we can now solve for Imax and Imin because we have Ix, Iy, Px, y. Okay, so for Imax, we use the plus. So we have 121.5. So 121.5 plus 54 over 2 plus the square root of, we have Ix. So 121.5 minus 54 divided by 2 squared plus pxy. What is pxy? We have negative 40.5 raised to the second power. Therefore, Imax is equivalent to 121.5 plus 54 divided by 2 plus the square root of 121.5 minus 54 over 2 raised to the second power plus negative 40.5 squared. So it is 140.47 inch raised to the fourth power. That is Imax. Okay. Next, for the Imin is 121.5 plus 54 divided by 2 minus the square root of 121.5 minus 54 divided by 2 quantity squared plus negative 40.5 squared. Okay? So, palitan lang natin yung plus sa calculator ng minus. So, there we have it. Imin is equivalent to 35.03 inch raised to the fourth power. That is the answer. Okay? Okay, so we have here problem number 10. A certain area has the following properties. So we have Ix 40 inch to the fourth, Iy 110 inch to the fourth, and Pxy, or the product of inertia, which is 40 inch raised to the fourth. So determine the maximum and minimum moments of inertia. Also, the angle that the axis of maximum inertia makes with the axis x-axis. Illustrate by diagram. So imagine wala pa to. We do not have this yet. Okay? So we are given the Ix, which is equivalent to 40 inch raised to the fourth. We are also given the Iy, which is equivalent to 100 inch to the fourth, and the Pxy is equivalent to 40 inch raised to the fourth. Okay? So we have here, if I am to draw my Cartesian plane, the y-axis is the products of inertia, and the x-axis is the moments of inertia. So we have here the products of inertia, and for the horizontal axis, it is the moments of inertia. So you have there your minimum moment of inertia, maximum moment of inertia, and the average moment of inertia. Okay, so what is the first thing that we need to do? The first thing that we need to do is to plot your Ix and Iy. Okay, so we have here 20, 40, 60, 80, 100. So 20, 40. Okay, so for the x-axis, it is positive 40. So we have here 20, 40. Then the positive pxy, that is also 40. So that is my x, ix, iy, pxy, ix, pxy. And the coordinates are, we have 40 and 40. Next would be the IY. The IY is 100 and the negative PXY is 40. So by the way, the PXY here is positive negative 40. So we have here 100 and so plot natin. We have here 100, then 20, 40. Okay. Then after plotting, so label natin, this is IY and negative PXY. Okay? So you can interchange this actually. They should give you the same value for I mean and I max. Pwedeng 40, then negative 40, 100, positive 40. Pwede yan. Okay? We should get the same answer. So for that, connect, after plotting, we need to connect it. Okay? Okay, and this will now be my radius. Then after connecting, I will now be drawing a circle. Okay, circle. So since that is a radius, I will now draw a circle. Okay, so after drawing, ito ang kalalabasan niya, this one. So this is my ix, so this is 40, 40. Then this is 100 and negative 40. Okay, so after that, we can now determine our values. So what values do we need? So for Imax and Imin, these are the principal moments of inertia. Maximum, minimum, we call this the principal moments of inertia. Okay, so for the Imax is equivalent to the center plus the radius. Then for Imin, it is the center minus the radius. Okay, center plus the radius, center minus the radius. But what is the radius? Okay, to solve for the radius, it is center rather. But what is the center? The center is simply ix plus iy divided by 2. Okay, what is ix? Ix is 40 plus iy is equivalent to 100 over 2, and that is equivalent to 70 inch raised to the 4th. Okay, what is the radius therefore? So the radius, we can solve that using the Pythagoras theorem. So we have the vertical, we have the horizontal. For the vertical, we know that this is the height, that is pxy. Okay, so we only need to solve for line CE. So for line CE, that is equivalent to iy minus ix over 2. Or it can be ix minus iy, just get the absolute value. So iy here is 100 minus 40 divided by 2. 100 minus 40 is 60 divided by 2, that is 30 inch raised to the 4th. That is line CE. Therefore, radius here, radius is equivalent to the square root of 40 squared plus 30 squared. Okay, then this is equivalent to 50. So we already have our radius. Then we can now solve for Imax. Imax is equivalent to the center. What is the center? That is 0. The coordinate of our center here is 70. 70, 0. Okay, so for Imax, we have the center 70 plus the radius of 50. Therefore, Imax is equivalent to 120 inch raised to the fourth power. Then for Imin, it is simply equivalent to 70 minus the radius of 50, and that is equivalent to 20 inch raised to the fourth power. So you were able to solve for the Imax and Imin. The next thing that we need to solve is the angle that the axis of maximum inertia makes with the x-axis. Okay, so by definition, the angle here is equivalent to 2 alpha. And since that is 2 alpha, let's say that this is beta. So we need to solve beta, and from there we can now solve the angle alpha. Tama? So tangent beta is equivalent to opposite, which is 40, over the adjacent side of 30. Okay? So beta therefore is equivalent to arctangent of 40 over 30. Beta therefore is equivalent to 40 divided by 30. And that is equivalent to 53.13 degrees. Okay? So 108 alpha, so 2 alpha is equivalent to 180 degrees, because this is 180 degrees, right? Minus beta, that is 53.13. So 180 minus 53.13, that is 126.87 degrees. Okay? Therefore, alpha is equivalent to 126.87 divided by 2, cross multiply. So that is equivalent to, divided by 2, that is equivalent to 63.44 degrees. And this is the angle that makes from the maximum moment of inertia with respect to the x-axis. Okay? So we are interested in alpha. And lastly, this is the Imin, this is the Imax, and the I at the center is what we call the I average. Okay? So that is our Morse circle. Just a clarification. It is the combination would always be for the coordinates ix plus pxy. Then it is iy minus pxy. Hindi sila pwedeng pagpalitin. Okay? It is ix plus pxy, then iy minus pxy.